Google has released this fascinating method for extracting or stealing, in other words, data from large language models such as ChatGPT or Palm 2. This method targets the embedding projection layer and reveals that the hidden dimensions of OpenAI's ADA and Babbage model are 1024 and 2048 respectively. This technique can be used with typical API access and only costs under $20. Now, the way it works is sort of exploits the logit bias. Logit bias refers to adjustments made to the logits of a language model's output before the final probabilities are calculated, often to encourage or discourage the model from generating specific types of responses. Logits are the raw output scores from the final layer of a neural network, such as GPT, before applying the soft max function to turn these scores into probabilities. In very simple words, logit bias is like tweaking the steering wheel of a car to make it more likely to go in a certain direction. In the case of these models that generate text, it's a way to make the AI more likely to say certain things and less likely to say others by adjusting its initial guesses before even it makes its final choice of words. As I said, logit biasing is used to influence a model's generation process by making certain outcomes more or less likely. This can be particularly useful for steering the model away from undesired output, for example, inappropriate or off topic content, or even towards output that are more in line with specific goals. And you can easily see that this could go either way easily. That is why this research is quite important. Now, the whole process is quite interesting. The method sets logit biases for different tokens and uses linear constraints to figure out logit values. It compiles constraints from many API requests and uses linear programming to make better guesses about the differences between logits. This allows the full projection matrix of big language models to be understood. The research introduces a log prob free attack that makes calculations more efficiently by turning the problem into shortest path problem in a graph. This reduces the time needed for calculations and shows a way to get around standard AI model security. There are a lot of security concerns here if you go through this paper. For example, the hyper-rectangle approach used by the researchers is more accurate and efficient than previous methods with much lower error rates in recovering logits. The results reveal out this vulnerability in LLMs due to the low cost and efficiency of the attack, and this again highlights that we really need to start thinking about AI security. But all is not lost. This still can be rectified. There are few preventive measures and defenses which can be employed. If you go through the paper, you will see that, for example, one of the things is to just simply remove a logit bias, because a lot of you know uh, LLMs use this to control or constrain generation. So if we just remove it, it will simply won't have any impact. Can we do it? That is another story that might simply impact the whole architecture. Or we simply just replace the logit bias with something like block list. But that will be maybe more prohibited, and this needs to be tested. Or instead of just using with this architecture, we just spin it on its head and use some other architectural change, another thing which needs still to be tested. And again, this is another defense of altering the architecture, or simply detect the malicious queries instead of any removing thing. And they touch upon a lot of other mathematical equations and stuff which you can read through this paper. But the crux of the matter is that this is going to be more and more serious as the machine learning evolves and the models progress from being experimental to widely used production tools, because the area of adversarial machine learning will be evolving in tandem with it. And that is why I believe that the release of this research is very, very timely and a wake up call for all of us, because if the model scaling or even getting the data out of about layers about these models like GPT-4 and Palm 2 is so easy and just cost under $20, just think about maybe a state sponsored or a very committed actor, what they can do with a lot of resources. So this is really a very high time that we start thinking about this AI security. Understanding the theoretical vulnerability of simpler models like 3-layer 100 neuron RELU network is beneficial, yet it becomes crucial to assess how these vulnerabilities might extend to larger operational models. So this study really marks a step towards this understanding by demonstrating that it is feasible to extract information from a layer of production grade language model. While uncovering this layer doesn't have immediate practical implications, it is the first instance of obtaining detailed insights into an operational transformer models. And if you think about it, for the last 1 year, the whole world is putting their information into ChatGPT version, maybe it is 3.5 or 4. And if that gets compromised, the implications are really, really scary. Also, the success of this particular method also sheds light on how minor design choices can significantly affect a system security. This vulnerability, which they have talked about in this paper, was exploitable due to specific parameters such as logit bias and log probes provided by major AI services providers like OpenAI and Google. Both companies have since taken steps to counter or increase the difficulty of such attacks. This underscores the importance for developer to consider how each element of system design can influence the overall security and integrity of their products. So I hope that this paper really encourages further research into practical attacks on machine learning models. The goal should be to contribute to the development of safer and more secure machine learning systems the world over, because this is still an evolving field and we know very little about even the internal mechanics of all of these large language models, what sort of data sets they are using, and how actually they are coming to the conclusion, which is quite scary, I must say. So one of the things I could suggest very humbly is that all of these models should be open source. And I really tend to agree with Elon Musk here that OpenAI should really live up to its name and make their model and data set as open as possible. Because then once it is in the community's limelight, the quality and safety will only improve. That is just my 2 cents. Very keen to know your thoughts on this. Please share them in the comments. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.